function f is continuous over the interval, the closed interval from 0 to 2, and has values that are given in the table below. The equation f of x equals 1/2 must have at least two solutions to the interval, again, the closed interval from 0 to 2, if k equals question mark, and you have a table. Well, this problem is an intermediate value theorem problem, and how do I know that? Well, for one thing, whenever you have a word must, or has to have at least, that's an existence theory type situation where you're going to have either the intermediate value theorem or the mean value theorem. Okay, so that gives us a hint there. But anyway, it says the function f is continuous over the interval, and that's another clue, is continuity is really a requirement for an existence theorem. And in case of mean value theorem, differentiability also. But anyway, we're back to intermediate value theorem. So let's just make a little sketch here. I'm going to do that below. That will kind of, I hope, illustrate where this thing is going. Okay, so I draw a little xy coordinate plane here. You got x, and the y, we have f of x. And we're going to label these points here at x equals 0, y equals 1, or f of x equals 1. So I'll just go ahead and put that in here. And the other point that is really defined for us is at x equals 2, y equals 2 also. Okay, so we don't know what the output value for k is going to be, but we're looking for at the equation f of x equals 1/2. Well, that's going to be a horizontal line right here. I'm going to label that as f of x equals 1/2. So if we look at what k is, we can try different values. And I'm just going to go from the right since it's sequentially. And really, just strategy-wise, you might want to start in the middle and go either way. You don't have an exact middle here. But if we start at 1, let's try answer choice C, for example. If we say that f of 1, k would be, in place of k would be the number 1, so we could just plot that point right here. And if the function is continuous, there have to be no breaks. And so we don't know where it was. It could be the function could go like this. Okay, the function could go like this. All right. We don't know what it's going to do. But if k equals 1 is one of the points there, we know that we would have to go through this point here, right? But does going through the point guarantee that we would have 2 or any solutions here where on f of x equals 1/2? No, it doesn't. So we can try the next thing. We can put k at 1/2. So if we put k equals 1/2, we would place that point right on this horizontal line. But does that guarantee that we will get at least 2 solutions? See, it can touch this once and then go back up. You might have 2 solutions. Okay, like if I drew this instead as like this, right? That would be a drawing of 2 solutions. But does going through this point here guarantee at least 2 solutions? I don't think so. Then we can try 1/2, or try 0. So if we go to 0, it would be right down here on the x-axis. Now, is it possible for us to include this point at 1, 0 as part of this function and not touch this line at least twice? Okay, we got to go through. Here's one example. Okay, and we can draw any of another number of examples, and this value here is the only one that guarantees that we're going to touch this horizontal line, f of x equals 1/2, at least twice. So I hope this has been helpful for you. Good luck, and thanks for viewing.